So this is our webinar number 5. And just to say that the UGPN is a University Global Partnership Network. So that has got 3 universities, which is University of Surrey, North Carolina State University, and the University of São Paulo. Now the 4th university, University of Wollongong, has joined as well. So this GREENICON project is between Surrey, São Paulo, and North Carolina State University. And this is the list of, the team. So you can see the principal investigators, but also the number of the co-leads who come from, 3 institutions at different levels, including the PhD researchers, postdoctoral researchers, as well as the academics. So this series, basically, we started in October 2025. So 4 of them have been delivered successfully. And this is the 5th one. And we got one last one to do on 19th of August. So each of the series has got 2 speakers. And these webinars are recorded and they go onto our YouTube channel. So we can send you the link and you can see the previous sort of, the recordings of the previous webinars. So, so this week, today, it's my pleasure to introduce our early career researchers that come from University of São Paulo and from the University of Surrey. So we've got 2 talks. The first talk is jointly delivered by Elton and Aline. I will introduce them very briefly. And the second talk will be Wickson Cheung. He's one of our PhD students, and he'll be talking about the work he's been doing in this particular area. So just to say, before I introduce the speakers, that this webinar is recorded, and I will encourage you to use the Q&A chat box and write your questions with your name for our speakers. So each of the speakers, or each of the talk, basically, will have 20 minutes each, and they will go one after another. And once these talks are finished, I will read out your questions to the speakers to answer. So we'll have around 10-15 minutes in the end to take your questions there. So without further ado, so I'd like to introduce our first speakers there. The first one is Elton Belarmino de Sousa. Elton is architect and urban planner, graduated from UNIFACISA, with experience in architecture design, technical documentation, and graphic design. He holds a master's degree in architecture and urbanism from the University of São Paulo, focusing on durability in engineered wood structures. Currently, he is a PhD student at the same institution, researching the production, performance, and contemporary application of rammed earth. So welcome, Elton. In the meantime, you set up your presentation. Let me take the opportunity to introduce our joint speaker for the first talk, and it's Aline Carolina Lopes de Rocha Schimitd. So Aline is a master's researcher at the University of São Paulo's Faculty of Architecture and Urbanism. She's focusing on quality and performance in the built environment. She aims to identify the benefits and drawbacks associated with the utilization of mass timber in the context of public school building constructions and methods for their proper consideration within the building process. So without any further ado, my pleasure to welcome you both and thank you for your time. Please share your screen and yeah, over to you.
Thank you.
Thank you. You can see the presentation?
Yes.
Yes, okay.
So thanks for the great introduction of us, Professor Coman, and good afternoon to everyone. and me and Aline today will we bring some discussions and some reflections about the biophilic function of mass timber. Mass timber it is one of the objects of research that we work. In this case, we'll go some discussion about well-being impacts of learning in education in educational environments.
Thank you, Elton. To understand why this is so urgent, we need to look at our relationship with built environments. Today, increasing urbanization has disconnected society from nature, and we spend almost all the time indoors. Recent studies shows that this connection increases stress and the impacts overall health. This dynamic is even more critical in education. Gaziani highlights that children spend a lot of time, up to 8 hours, inside schools. So, if you would can transform that space, how does it affect children's developing brain and their ability to learn? Elton?
So in this image, we can clearly that we have the same space, but in the different conditions. And even we don't know about, for example, light on construction or well-being. I think we naturally will choose the second image to the space that we're gonna work because it's more lighter. We're gonna see more green and in a general way bring us some good sensations. I think so. And when you think about sustainability, for many years, sustainability in architecture was primarily associated with reducing and environmental impact of building. Uh, Objects like energy efficiency, water conservation, waste reduction, and lower carbon emissions. These objectives remain fundamental and represent important advances on the construction industry. However, um, research increasingly demonstrates that effects of indoor environment on health and well-being of the people that use this space bring a new perspective of what is sustainability. So, if we spend approximately 90% of our times indoors of this building, it's not enough for the buildings to be environmentally efficient for only the buildings. They need to be good for us that being there. So the result of the concept of sustainability has become broader and more comprehensive. In addition, we have another subjects that are included now, like health, well-being, comfort, and human performance. So um, we recognize that um, a truly which important question came for us. So, if we know that this is the good points that we need to see, so what characteristics make a building truly healthy? So, this is an important question that we need to know. To answer this, we need to see this picture. Um, the literature The literature indicates that several points are important to confirm that a building is healthy, like natural lighting, moisture control, acoustic comfort. We have thermal comfort, air quality, and materials and construction systems. So these aspects affect directly the user experience and and can affect everything that we do or that we feel inside these buildings. In addition, in especially speaking, material and construction systems play a fundamental role in this process because they influence building thermal behavior, for example, moist management, acoustic insulation, the durability of the building, and other characteristics that affect indoor environmental quality. Um, Therefore, however, we need to talk about these things and especially how our buildings are made because healthy buildings now need to be a result from the interaction between design, materials, and indoor environmental quality.
Um, this brings us to the biophilia hypothesis, popularized by biologist Edward O. Wilson, which describes our innate human connection to nature. To apply this to architecture, Browning, Ryan, and Clancy identify 14 patterns organizing in three categories. Nature in the space, which features direct elements, natural analogs, which include materials like wood, and the nature of the space, involving spatial configurations that resemble natural environments. Wood is particularly important in the category of the natural analogs, serving as a biophilic element that evokes nature through its texture and the sensory experience. Gaziani found that students between 8 and 11 years old have a strong preference for seeing and touching wood. For them, it's not a just construction material. They naturally link it to wood to feelings of happiness, comfort, and safety. And when we will use these elements like timber, plants, and the natural light, classrooms become spaces that truly support learning.
Um, through these materials or using these materials, we have an integration of architecture and nature, né? The union between design and the physical and mental benefits of biophilic design. It brings about through these materials these new system constructions and and using these materials we gain the ability to combine sustainability goals, né, os the green, with the active promotion of the student health is like, in this case, the well-being. We have here in Brazil a beginning of the case of the public buildings using materials like mass timber or remnant earth or and other nature materials. Um, Increasing by a new age on construction in a new way to think about how we do our buildings. The main material that we study is mass timber or engineered timber, but Rema R is also very major in contemporary architecture here in Brazil, right? Because these systems combine traditional building techniques with modern construction approaches. And, however, like mass timber, uh, the successful implement of this system on buildings or houses or schools depends the appropriation technical solutions, particularly those relate to moisture protection, like in those cases, mass timber and Rema earth, to increase durability and construction determined. is precisely the importance of this technical aspect that will be addressed in the next era in our construction, and is this that we really study here, the technical part, the detailing, the design of these buildings using these materials.
And well, this picture shows the practical application of these natural materials, such as hammered earth and wood, in school buildings. And in Brazil, the use of machine in educational facilities is a recent trend, but is already reaching in the public sector. Designing for our realities requires addressing specific challenges, mainly in relation to our diverse tropical climate. Brazilian habit is to keep the mesh timber exposed. This choice is not just for aesthetic reasons, is then also offer biophilic benefits, directly improving well-being and the learning experience. However, this practice creates a new challenge that demands a special project care. How does this emotional preference translate into real classroom results? Physiologically, exposure to visible wood has been associated with lower cortisol levels and reduced heart rates. Sociologically, it increases feelings of comfort, safety, and well being. But the most important outcome is cognitive. Studies confirm that wood improves mood and reduces anxiety. And when students are calm and comfortable, they focus much better. This results in faster process information and better test scores. Of course, the building timber schools demands a good design, and on the positive side, wood provides great thermal comfort as a natural insulator, creating welcoming climates. Acoustically, which requires insulation, but users find these spaces very calm and quiet. And finally, wood naturally regulates moisture, and its smell promotes relaxation. But we have to be careful. Studies warns that mass timber classrooms can overheat in the summer if they lack proper ventilation. Also, without the right acoustic protection, noise will distract students. Finally, studies often highlight VOC emissions as a key concern that we must manage.
So, when I think about the use of natural materials to promote health and well-being, it's important to notice that this is one thing. The other thing is how we make our buildings with these materials uh, in 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 the mode that these buildings truly do uh, their function and truly promote health and well-being. How we do this? We do this with thinking that good materials uh, need good design, need more than good intentions, because the performance of these materials depends on how they are designed, detailed, and especially implemented. It's precisely with this context that many of the research that we do here at University of São Paulo, especially at the technology department here at the Faculty of the Architecture and Design in Urbanism, to have the goal to promote the activities that developed um, our researches about these materials, about these new system constructions, and especially to understand the behavior of these materials and proposing technical solutions to enable their safe, their durable, and efficient application of in this building that we are studying or the future buildings that we're gonna to construction here in Brazil. Right? And this is gonna depend about these details. Right? We need to do a good design, do good detailing, right? Because performance depends on design and detailing. Here we bring some examples of the detailing with using mass timber, right? So we can see connections, we can see interface between other materials. This is materials studies that we do here and share with our community of architecture and others professionals on this area.
Looking at the facts, studies highlight basically three major research gaps. First, most evidence comes from labs, computer models, or subjective opinions. We need more controlled studies in real world in educational settings. Second, we need a long-term monitoring. Do students get use the material over time? Do the benefits last? Third, we need to test these schools across different seasons and climate contexts. To conclude, the integration of the biophilia, well-being, and mass timber represents a promising approach for the future of building in Brazil. This strategy supports both human development and sustainability if the designs meet the material's technical demands. Um,
Our references to do this presentation.
Thank you
And
very
thank you so
much.
much.
So much.
Thank you. Thank you very much for a very interesting presentation, both of you. So if you have any questions for our speakers, please do write in the Q&A chat box with your name, and we will read them through, after the second presentation. So without any further ado, I'm going to introduce to the second speaker of the webinar, and that is Wickson Cheung. So he's a PhD student at the Global Center for Linear Research, University of Surrey, working in collaboration with the National Physical Laboratory, and his research focuses on indoor environmental quality and airborne infectious risk. He completed his master's degree in environmental systems engineering from the University College London, and he gained research experience at UCL, working as a research assistant, and is a multidisciplinary researcher with a mechanical engineering, urban fluid dynamics, and civil and environmental engineering background. So, without any further ado, over to you, Wickson.
Okay, brilliant. Thank you. Thanks for introducing. So hi everyone. Good afternoon. So my name is Wickson from the Global Center for Cleaner Research, University of Surrey. Today I'll be presenting one of the experiments that we've been developing and looking to go underway within the next 2-3 weeks. That is called the micro-scale greening for indoor environmental quality and overheating resilience in naturally ventilated dwellings. So let me briefly go through the background and research gap before we go into the depth. So as the previous speakers said, people are spending 90% of their time indoors, and outdoor stresses like the traffic-related air pollutants are continually affecting indoor environments. This is in particular post the COVID, with more people tends to work from home. And even with the climate crisis being intensified, the urban environment are increasingly exposed to overheating during the summer and worse air pollutants, air quality. So while most of the research currently are treating these domains with overheating and air quality, indoor air quality, separately. So they overlook their interactions and their combined health issues. And also at the moment, there are really a lacking of data, as we discussed, as the previous speaker also discussed within the real world setting. So the overall idea really for us to develop the experiment is to create healthier homes, or even to say a healthier indoor environment and a cooler summer and a low energy living. So, and why this study is particularly important is that really in the UK, we are, especially in naturally ventilated, homes, we are having an issue with overheating, particularly in the summer, while most of the new build houses especially are built to be increasing the airtight and intensively airtight, which means they are aiming to improve energy efficiency during the winter to capture more energy, more heat internally. But then they neglect the fact that we are actually reducing ventilation condition and even intensifying the risk of overheating in summer. While the hot indoor condition can affect comfort, they can also affect well-being and sleep in particularly. So hopefully all of us can experience that during the heat wave over these few days. So certainly having a fan is not effective enough to handle the heat. But while having an AC is reasonable, but then it increased the energy demand and cost, and more importantly, in the UK in particular, or even in some of the Europe countries, having an AC being installed require approval from the local council and sometimes even your neighbors as well. So we thought so we already understand many benefits of the indoor plants. So we thought we might be, and even outdoor plants as well. So we thought we might be able to implement greening to hopefully provide some shading and in turn improve ventilation indoor and improved environmental quality. So as we said, we already understand the benefits of indoor plants. So I'm not going into depth of that because that's out of the scope of the presentation. But if you want, you can see our recent papers. But the actual benefits lies upon the air quality improvement, thermal comfort, humidity regulation, and all this stuff. So really, the idea of the current experiment that we developed is to hope to address the gaps through an integrated framework of real-world monitoring and simulation that integrate vegetation, plantings in both indoor, both inside and around the house, in order to improve environmental quality. So the idea the overall aim is to determine whether indoor, outdoor, and even the combine of the microscale greening interventions can improve IEQ, reducing overheating exposure, and even influence the household energy demand to say we minimize the usage of fan or even AC. So to achieve that, we developed a monitoring at the first stage to understand the outdoor and indoor correlation by having both indoor and outdoor sensors. Then we evaluate the impact of these greening interventions from green walls to indoor potted plants. And then finally, we hope to inform future screening strategies for urban indoor space. So what we will be monitoring for this particular study is that we'll do the indoor and outdoor PM, and then we will monitor CO2 as a proxy to the ventilation condition. We'll also monitor thermal condition in terms of air temperature and relative humidity. And what's something interesting is that we'll also monitor energy usage by using a smart meter reader. And also we'll be understanding and monitoring sleep-related parameters. We'll be using sleep, as a proxy or in the context of well-being. So the whole idea of the study design is to will be obviously it'll be conducted in a residential dwellings, and then we are hoping to get up to 5 households, with each household having a maximum of 4 participants. Ideally, we'll be doing it during the summer for up to 60 days monitoring, but that's subjected to logistics. And we'll be having 4 scenarios. Now the first one being background, and then the second one being the indoor greening, third one outdoor, and the final one is is a combined one. I'll go through a little bit more briefly in the next few slides. And then we'll also be undertaking sleep diaries and contextual logs, just to understand the household variability, day to day. So there's 2 parts of the study, as we said. The first one being the monitored, and the second one being the modeling. I'll go through a bit more detail on the monitoring because that's forming the major part of the study. As we said, we start with the baseline monitoring, and then moving on to each of the intervention scenarios. We'll be logging the daily contextual logs, which means hopefully we can capture when the window's being open, is the blinds being open, and is there something to do with the occupancy for, let's say, is there a party going on that affects the temperature inside. We'll be continuously monitoring indoor and outdoor, the pollutants. And one thing we'll also be doing a pre and post interventions mood questionnaire to hopefully see whether implementing greenings can, in turn affect mental health of the occupants or the residents living within the environment. So there'll be 2 stages. So we'll start off with one household for stage 1. And then we'll see, how promising the result is. So if the results turn out to be quite promising, then we'll expand it further to further household. But just to mention, we already did, one sort of similar greening intervention study in a classroom, which we have notified a few limitations, and we improved a little bit. So that's the first step of our current experiment. So I'll show a little bit about what's so special about our energy monitoring. So we acknowledge that most of the homes nowadays, so they've got smart meters already, but then it's up to the fact of that they only capture daily values. Rather, our sensors can capture half-hourly values, which means we can really understand the micro activities within the indoor space, and in turn, understand then what is actually affecting the energy, or even the air quality, and so on and so forth. So we start with explaining the baselines. So obviously, we will do a 2 weeks of monitoring without any interventions, and to see what's the normal or general readings. And then we'll go to the part 2, which is the indoor greening. We'll do this in the bedroom. We'll be putting sort of like window side plantings, as of showing in the figures, and we'll be doing larger living walls, and then might as well be large potted plants within the bedroom to see whether they actually affect people's sleep quality in general. Then moving on to part 3, we'll be doing outdoor greening, as in like a larger plant wall, or even fast growing beans to sort of block out the sun from coming into the indoor environment. Then finally, we'll do indoor and outdoor combination linkage interventions. So we do the outdoor, and then we'll do indoor, ideally in the living room, which is the same floor as in the outdoor. And then we can potentially capture how, is there pollutants ingress, or how effective are the plantations in reducing heat for the indoor environment. So that's something that we are currently looking at the moment, which hopefully we can manage to figure it out before in the next couple of weeks before our experiment started. But that's something that we are hoping to achieve in terms of putting on the outdoor of the house. And I'll briefly go through the recruitment. So obviously the inclusion criteria is that it's a naturally ventilated home. Ideally a house, then we can, there's more traffic-related air pollutants, and that they are happy for us to put sensors and interventions, but more importantly, that they need to spend most of their time within the house, meaning, for example, they're working from home. And we are excluding homes that have children under the age of 18, and where the house is having major building works. we will not capture any health conditions, health issue, actual health related issue, but we might be able to, we might be able to see this information throughout the questionnaires, but we are not hoping to capture any of those. So as I said, there will be a second part of modeling. So we are basically aiming to achieve a validation model with the CFD or Energy Plus, and that way we can capture all the minor details that a monitor campaign cannot capture. Hopefully, we could replicate and understand the greening effect in a presentable manner in terms of the solar gain and shading and all this kind of stuff. So there are two sort of benefits for the study. First one being the actual benefits to the participant itself. So we hope to raise the awareness of the indoor air quality and the ventilation and the energy usage. We are hoping to provide actual benefit, short-term benefit at least for them by providing shading and helping them with the overheating, and they'll also be able to choose among the implemented plans based on the evidence that we created. And with the wider benefits, we are hoping to create the first stage of having actual data with with a occupied household with actual occupancy, and hoping to provide some general guidance related to these and understanding how the outdoor correlates to the indoor. So the expected outcome, as I said, we're hoping to get a heat mitigation towards the indoor, providing some cooling effect towards it. And then we are hoping to provide some shading and with the plants, we're hoping to filter out some of the outdoor air pollutants coming into the place and potentially optimize physical well-being with the large amount of plants that we implemented indoor and outdoor within the household. So talking about the more academical deliverables, we are hoping to get a few papers within that, but that's really it at the moment. But I hope that sounds interesting, and I hope to share a little bit more once the experiment started to finish off our acknowledged research team, and that's it for my presentation. Thank you so much.
Yeah, thank you very much, Wickson. So I think we got a few minutes actually to take some the questions. I'm wondering if I can't see any questions in the Q&A chat box. But if you have any questions, can you please drop it in the chat box or in the Q&A chat box? In the meantime, I can possibly start the questions for our first speakers. So, I mean, if I just ask you a very kind of a generic question, so where do you see that work would help actually in terms of, for its application in the real world situations? This is a question for Elton and Aline.
Sorry, can you repeat, please?
So what sort of the work you have been doing is very interesting, but when it comes to the real world implementation of the the findings, where do you see actually that could be used, and what sort of challenges do you see in getting it, let's say, into the real world, the situation there?
So I think first of all, Brazil has a special condition that is different from the other countries. So we have many weathers, we have many regions, big regions, one especially all totally different to another. And for example, when you think to use building construction system, is different. You use this construction in one region to another. So our contribution to put in the literature specific technical detail design for these systems to be implemented and studied on this region, and often to export it to another region with the particular adaptations, because every place here has particular characteristics that is different to another. In my master, for example, um, um, I did the research, né? I studied the construction system, and as a product, we did a book with detailing construction details for mass timber, for example. And this became a literature to will be used for architectures, engineers, or another companies that work with mass timber here.
Perfect. Thank you. And Aline, do you think you want to add anything?
Your microphone is
Elton speaking exactly the point. Brazilian is the big territory, and the different climates, different contexts. The application in Brazil, the mass timber specifically, is a very careful with the details, with the context, climate, and uh, I think so. No
I think
compliments.
I think the main objective of our department is study the material and system
Mhm.
material. And if we know that nature materials or nature building constructions promote health and well-being, like I said, this is one point. Our mission here in our department uh, is to do the is to show how this material or this construction system can be applicate on the building safely, technical with a good technical, and that it really improve these good characteristics like well-being and health to the users, because we
Depends.
cannot. Yes, you can talk. Please help me, because it's not, it's good to have good materials, but we need to use. You need to know how to use them. It's not enough to know that the material or system construction is good. We need to know how to apply them, how to put in the building.
We named this for tropicalization for this technical, just for the specifically demands on the material in Brazil.
Hey, perfect. Um, are there any other questions for our speakers? So I can see that there is a question from Jacqueline. She says that very interesting presentations. Thank you to all the speakers. A query on the rammed earth in Brazil. What modifications, if any, are being made to the earth to reduce erosion in rainy conditions? This one is for Aline and Elton.
I can't see the question.
Shall I read it again for you?
Oh, please.
Yes.
So the question is on the rammed earth. You talked about rammed earth, right? In Brazil.
Yes.
So what modifications are being made to the earth to reduce erosion in rainy conditions?
I think so. This ventilation is proper for the external insulation for the material, and in in another places not use it, this material sempre com isso. Yeah, and the natural ventilation is a necessary for the Brazilian, for the moisture control and Elton.
And the thermal control also, and I think is one good that one good is too important to round off our here is the design. The design is very important to
Control this.
yeah, for we don't have problems on the future. And we also working on these materials for when the remnant are like I said, book of detail, promote good design for this system construction also. Your microphone is closed.
Are there any other questions for our speakers? If not, then maybe we'll just give you like 10 minutes back and have a nice tea or coffee break. It's very hot at the moment, I know in the UK. So let me then, first of all, thank you very much to all our three speakers today for their fantastic work and, making time to speak and share their work with us. So before we go, just to introduce to the last webinar, which we'll be having is on 19th of August. And we have Marco, he'll be talking about very interesting work related to the topic area. And then we still got a speaker slot there. So as we discussed, let's approach actually, these colleagues to slot in for this last slot and last webinar. So thank you very much, everybody, and have a nice rest of the day. And as I said, we will send you the recording once it's on the YouTube, that you could then, share it across or, use it as a reference in the future. So thank you, Sohela, for organizing this. It's really helpful. And thank you, everyone, for your time today to attend this. See you again. Bye. Next webinar.
Thank
Okay.
you.
Thank you. Bye.
Thank
Bye-bye.
you.